Yeah, hello together. How many of you think that AR or VR will change the way we interact together with each other in the future? About 50%. How many of you don't raise their hands in presentations? Okay. Then we are about 100%. First of all, thank you for having me. As already said, my name is Jochen. I'm here to talk a little bit about what Siemens has to do with digitalization and especially with augmented and virtual reality. First of all, Siemens is a big industry company, and I am located in the operating company Digital Industries. What do we do there in Digital Industries? We have 5 business units. One is factory automation, where I am located at. Then we have process automation. We have a huge software business unit where we have CAD systems, simulation, but also cloud application services and so on. We have a motion control business unit where we produce numerical control units, drives, motors, and so on. And we have customer support where we support our customers. Why do I mention this? This is a little bit important because we are in a field of automation, electrification, digitalization, and if you have no sense about what the future can look like or what technology is important, then you are too slow. So this is something that really drives us within Siemens to be really in all these technologies and use these technologies and apply also these technologies within our factories, in our environments, to really see what the technology can affect and where we can use these technologies. And we are not only software developers, we not only develop products in Siemens, we also use the products we produce in our factories. And therefore we have, let's say, program we call Production and Logistic Excellence within our Digital Industries department. And within this Production and Logistics Excellence, we have 6 core programs. And one of the 6 core programs is Lean Digital Factory. And within Lean Digital Factory, we are talking about 30 plants we have all over the world. So not only in Germany, a lot of them are in Germany, but also in US, also in China, in Czech Republic, and so on. And what drives us in these factories, of course, to shorten our time to market, to increase the flexibility in our plants, to improve the quality in our plants, to boost efficiency, and evaluate new business models. And besides that, to ensure security using new technologies like cloud technology, for example. Our factories are already partly awarded by Industry 4.0 awards or are awarded by the World Economic Forum in Davos as Lighthouse Factory when it comes to digitalization. And we have already a lot of customers. We produce very efficiently. We have high quality standards, and we have a very good horizontal and vertical data integration. But nevertheless, we have a lot of things to do, and we have a lot of challenges when it comes to digitalization. And if you heard already a Siemens presentation, everybody is talking about digital twins, so you are familiar with this topic. But what I want to highlight is that the digital twin of product production and the real world is gonna merge. So this is going together, and this is the very important part. And how can we drive this, especially with the use of technologies like virtual and augmented reality? And when we talk about the factory of the future, for example, the picture of the future can look like this. There you have everything to specify a lean digital factory. So you have here the factory, you have standardized processes, you see a process flow, you have a digital twin of your process, you have a big data lake where you collect all the data generated from the machines in the factory, you have autonomous mobile robots, self-configuration within the factory, you have traceability from your supplier to the customer, you use analytics to optimize your factory, and you have different business units working together. Here, for example, control products, motion control, and factory automation. And really to improve the setup of our factories, we have this lean digital factory approach. And this is a structured approach we use. And we started in 2017 really strict with this lean digital factory approach I want to show to you. So we started with the ideation phase. So we have 30 plants, we have different infrastructure, we have a lot of people involved, and how to manage such a digital transformation within factories needs an ideation phase. So there we started building an organizational setup. We did technology workshops, not only for AR and VR, but for all technologies available. We started to define reference processes. We built up technology radars and did mapping of our software landscape. And out of that, we generated digitalization roadmaps. In the beginning, we had 11 of them, but then we said, okay, for 30 plants, 11 roadmaps, this is a huge effort for communication. So we merged some of the topics, and now we have 5 digital roadmaps generated. And the main modules are Streamline PLM, so all about the PLM process. End-to-end means from the supplier to the customer. IoT operation system, like an enabler module, like disruptive technologies. And the basis, of course, is people and methods. And out of this digitalization roadmaps, we started really to look at the reference IT architecture. So we did also an IT roadmap based on the functions we need for our digitalization roadmaps. We have also a software department, business unit within Digital Industries. There we mapped the solutions they have available for us to these digitalization roadmaps, and did this not only for PLM, but also for manufacturing operations management. And these are the 5 core modules I already said. So 2 process-driven modules, Streamline PLM, so starts with product design via production planning, production engineering, production execution, and services. And the other process-driven topic is the whole SCM process end-to-end from supplier to the customer. And the enabler modules are IoT operating system like cloud computing, tracking and tracing, traceability, analytics, AI, but also disruptive technologies. And disruptive technologies is not only cobotics and AGVs and mobile robots, additive manufacturing, but also virtual reality, augmented reality, and interactive wearables. And last but not least, how to enable our people working in the factories to use these digital tools, digital methods, and support the digital transformation within our factories. And this is somehow the roadmap, the disruptive technologies, and a part of these disruptive technologies is, as I said, virtual reality and augmented reality. So what is the motivation to use AR and VR in manufacturing? Is more or less the replacement of physical mockups by digital mockups to improve quality, to reduce time to market, to be more flexible, or to increase performance. But what is the problem about that? We have a challenge. So this use of AR and VR is very use case specific. So you have the consumer market, you have industry, you have different hardware solutions, you have different software solutions, and this is very complex and this is very use case specific. So the need for action to implement this in an efficient way in a factory is to standardize this kind of solutions you have, to build up a roadmap, to define interfaces, and then at the end to have a hardware independent infrastructure. And the basis in a factory is always the authoring system. So for designing a technical product, it's most of the time a CAD system, so a computer-aided design system like NX, or other software companies have other solutions. For us it is NX. This is the authoring system, and this is the basis for the content you need to consume in virtual or augmented reality. And as I said, it's about lean digital factories. So when you come from manufacturing business, how many are from manufacturing business here? Not a lot of. But nevertheless, I think most of you are familiar with Toyota production systems. So there are culture, method, or philosophy like lean, so keep it simple, working in cross-functional teams and so on. And this is not old school, but this is combinable with technologies like AR and VR. For example, to work in a cross-functional team is very efficient possible using technologies like AR and VR, and thereby you can address productivity by shortened time to market, for example, in development projects, to save costs or to increase planning quality. But not only the use of this technology is important. As I said before, we have also a lot of software business inside digital industries, and there we have a lot of solutions in our portfolio, from pre-sales concept via production planning to services, and we have a lot of AR, VR use cases using our own software tools. And here are some examples we have. For example, in healthcare business, we use VR and AR, here mostly VR, to really look at designs we do and make decisions based on these designs in virtual reality. But very practical things are immersive engineering, to do team reviews on product designs, or immersive training or documentation for processes you have in manufacturing. And last but not least, photorealistic visualizations you use for, let's say, product informations in marketing and sales. But you also use augmented reality in the shop floor. So for example, to do visual inspection, to support maintenance, and so on. But these are the use cases. Here we say wearables are only the peak of the pyramid. So what's very important for us is the architecture, and therefore you need an infrastructure to really have the interoperability between the tools from the CAD system to the device at the end. And therefore you need not only the infrastructure, you need the right content, you need a security concept for that, and you need the right use cases. Here, for example, I have something we use exactly for product design. So there we have 3 parties involved, sometimes 4. So one party is the R&D hardware designer, sometimes supported by the supplier. We have a DFM expert, and we have a production technology expert. And based on the design, this group is really discussing, is this design good for manufacturing? So we have the authoring system here used NX, and then we can really enrich this data with manufacturing information, so-called product manufacturing information, and then we can really check this in a virtual reality setup. We do this since 2012. The setup is the same, only the hardware is different. In the past we were at head-mounted displays for 25,000 euro, and nowadays it's very easy to use hardware for about 300 up to 700 euro for that. And there we can really early in the product engineering process look at the product, improve the product, and so we save time and money. Everybody is familiar with the rule of 10. The earlier you detect failures in your product design, the more money you save. The later, the more money it costs to fix these problems. But not only for product design you use augmented and virtual reality, here in this case virtual reality, also for production planning. So planning your production lines, you can use virtual reality very efficiently. looks like that the video is very heavy. I try to restart it. Too heavy. Okay, then without video, here it is possible really to build up a manufacturing scenario in the virtual world. So here you use head-mounted display. You can really interact with your manufacturing equipment in the virtual world. So you can take, for example, the arm of a robot and check if the robot reaches all the position you have planned in your manufacturing layout. If it fits, then the layout is perfect. If it doesn't fit, then you can rearrange the layout directly in the virtual world. And this is not only, let's say, a game. You can really store this data directly in the PDM system and so update your layout and do also revisions on the layout. So this is directly integrated in the process, and you can manipulate, reorientate, and then restore the data back to the PDM system. So then you have planned your production line, for example, and you have additional tasks to do. For example, engineering. So you not only need the hardware setup, you also need the software setup. And most of the machines are controlled via PLCs. And this can also be combined with the digital twin of the production. And here we see that the simulation is running. You see hardware components, a hardware rack on the table, and this hardware rack is directly connected with the digital scenario. So they push the stop button, and then the simulation stops, and then you react via putting a button on the HMI, and the simulation starts again. So the model is connected really to the hardware scenario, and so you can really check between real and virtual world how the interaction works, and you have the possibility to really simulate how a system will react in reality. So this is standard virtual commissioning, so you have the possibility really to check if all the machines are working in the way they should do. But now you can also interact with your workers in the system, and then you see you can also virtually push the button or hit the light fence, and then the machine stops. So here you can also test in a virtual scenario how the system reacts. And of course you can see all the, let's say, profiles of speed and torque of the robots in the system, and check if they are slow enough, if this fence activates the machines. And this is only a, let's say, standard virtual commissioning setup, but you can also integrate now virtual reality into that, so that you can directly interact with this environment controlled by a hardware PLC, a virtual scenario of a production process, and then you can also interact with this scenario in the virtual world. You can reposition systems, you can use this human model to activate the light fence, and then the scenario stops. So there you have a fully integrated model where you have a lot of possibilities to do engineering, not with expert systems, but with virtual reality and very easy use of standard equipment, like here for this example, the HTC Vive. Another scenario I have here is about interactive wearables. Of course, you can use also glasses for that or other hardware, but in reality, in industry, is not very applicable, because after a certain time, the guys don't want to wear these glasses anymore because they're too heavy and so on. But in the future, maybe this will be possible. At the moment, we are using a lot of smartwatches really to interact with our machines in the shop floor. Here in this example, we do setup management for our SMT lines. We have electronics production in this use case to visualize and manage via smartwatches. So there we see exactly what to do and when to do and where to do, so we can save directly labor costs by using these smart devices to really guide our workers in the shop floor and help them to fulfill their tasks. Another scenario I have brought with me is another smartwatch scenario where we use a notifier application on a smartwatch. Is also applicable for mobile devices, and there you have the possibility to support your maintenance teams. If you have a maintenance problem on a machine, the maintenance personnel gets the information, knows directly where this machine is located and what is the error code of this machine. The last scenario I have with me is about augmented reality for visual inspection. This is also applicable directly for assembly support, like work instructions or something like that. On the left picture, you see the scenario in the past where you have a lot of monitors to really look at the product. They see a lot of specification, what is to test, what the person has to use, and a lot of steps. And on the right side, you see the innovation. You can use here a tablet for that, where you get the additional content directly on the tablet or to the glasses to have the instructions directly in the shop floor. But the advantage is not that you can use this technology. The advantage is really to generate the content directly out of the data you generated during the design process. And this is the most important part, to do this content generation very efficient and on a standard basis, so that you can reuse this for virtual reality scenarios, for augmented reality scenarios, for maintenance, for work instructions, for engineering tasks, and this is really powerful. And then when you have the momentum to really be efficient in generating content, then it's very easy to find use cases and to gain productivity out of technologies like virtual reality and augmented reality. If you have a defined IT architecture, then you can not only use the content you generate during the design process, but you can also use the content generated directly by the machines. So if you have PLCs in place, you have a SCADA layer, you have an MES available, and then you can collect this data in a cloud environment and use this data, add this content, and this is also very efficient. So this we use, for example, to visualize our KPIs. This is very easy possible. So you add this content directly generated from the machines via augmented reality. This is also already applicable. For that, you need also a very efficient infrastructure, and this is something we are building at the moment for all our manufacturing plants. We have standard IT architecture in place, and now we are working on a central manufacturing data platform to collect this data directly out of the machines and to have the possibility to build one manufacturing data platform to be able to connect all the data sources to this manufacturing data platform and then provide the data as a service to be faster than before, to have these scenarios up and running in the shop floor, for example. This is very important for the shop floor scenarios. In engineering, we already have this using our PDM systems. There is all the data available, but now for the shop floor, we have a lot of use cases. We will use this infrastructure to bring the scenarios to reality and to use augmented reality in a broader way in the shop floor in all our DI plants. So to summarize, what do we need for manufacturing business to use augmented reality and virtual reality? We need an infrastructure. We need the content, We need a security concept, and based on this basis, we can generate our use cases and at the end put the right device for the use case on top. And when we have this disruptive technologies available, then we can reduce travel costs, we can increase performance, we are more flexible, we can save time, and we can improve our quality. So thank you very much for your attention, and if you have any questions, feel free to ask.